Hi everyone, this is Ajit from Catalyst Class. So in this video, I am going to discuss about the real number, that is the NCERT chapter number 1. Okay. So I will talk about the irrational number. So what is the irrational number, and if any number is given, we need to prove it. Is this the irrational number or rational number? Okay, and prove that. So next point we will talk about the insert the two rational number between the irrational number. Okay, and similar way insert the two irrational number between the two rational number, and lots more about the irrational number, like when the two irrational number will get added, what is the what kind of it will be the rational number or irrational number, that value or multiplication of the two irrational number, what will be the output, and either like division of the rational number to the rational number or subtraction from the rational number to the irrational number, what kind of the number will come, either rational or irrational. So all those things we will talk about in this chapter. So if you think this video is helpful to you, please like and subscribe this channel for more update on the videos. So first thing is, what is the irrational number? So irrational number is the part of the real number system. So in a real number system, there is it's divided into two parts. First is the rational number, and other is the second is the irrational number. So we are talking here irrational number. So irrational number is defined with the q bar, but the rational number is defined with the q. Okay. So any number that can be in the square root or square cube root, okay, those number is called the irrational number if those number are not the perfect number. Or I mean to say कि, those number underscore any number, that should not be the number, exact number. It should be underscore like 5. Okay, so that underscore 5 is underscore 5. It's not the any exact number. But underscore 4 is 2. So 2 is rational number. Here 2 is the underscore 4 is the rational number. Okay, so because underscore 4 equal to 2, but underscore 5 is not equal to any like specific number, or it's not the exact value. Okay, so like underscore 7, here we are not getting any exact value, so this is the irrational number. But underscore 9, I'm getting the exact value 3, that is the rational number. So I can say the underscore m or underscore n is the irrational number if exact underscore m or underscore n is not the exact number. I can say the cube root 3, okay, or cube root m is the irrational number if the cube root 3 and cube root 3 and cube root m, okay, is not the exact number. Fine. And all the irrational number can be defined in the p by q, where q is not equal to 0 and p and q should be the integer number. But here is the condition is uh, uh, these numbers, okay, the p by q, the equal to whatever the number will come, that should be non-recurring, non-terminating. So what I mean to say, if I say the p by q, any number is there where p and q are integer number and q should not be 0. Okay, but the condition is here for the irrational number is, okay, p and q, whatever the value is coming, that value, suppose this is the x value is coming, okay, I'm getting the x, this x value should be non-terminating and non-recurring value. So what is the meaning of the non-terminating? So non-terminating means this value will, when we divide p by q, this will go after decimal, it will go up to infinity. Okay, so it will not terminate after after decimal point 2 digit, it will go and it will get terminated. Okay, that division, it will go up to infinity, like 2.3456, okay, 1 6 3 2 4 5 6, okay, something like that, it will go, okay, up to infinity. Okay, so here it will not terminate. But and one more condition should satisfy, non-recurring. So non-recurring means it should not repeat like either 4 or 5 digit and after again 4 and 5 digit or 2 digit any number. It should not repeat in such a way. Like the repeating number is 2.123 6 1 2 3 6 1 2 3 6 something like that. Here is the repeating number. Okay, so this kind of repetition should not come. Okay, so that is called the recurring. Okay, so if the repeating is coming, that is called the recurring. So this condition, this type number should not come, this recurring number should not come in this. Okay, so it should be non-terminating, it should never, that division never end, and non-recurring value. So it should not the like recurring, that some set of the number will recur every time after the decimal. So for example, pi, okay, 22/7. Okay, this number is 3.14 and it will go up to infinity. Okay, so this number is irrational number. Irrational number because this is non-terminating. Okay, it will not terminate, and non-recurring, it's not recurring also after 2 or 3 digit. Okay, 2 or 3 digits recurring every time, so that will not happen. So that's why this number is irrational number. So we'll take one example. Insert the rational and irrational number between the 3 and 4. Okay, so here the two things we are asking. Insert the rational number between 3 and 4. I insert the irrational number between 3 and 4. So first we'll talk about the rational number. Okay, so we are going to insert the rational number between 3 and 4. So for example, you will take the a and b two integer. Okay, such that a into b, so a and b integer, such that a and a into b is not equal to perfect square. Then the rational number between 3 and 4 would be a plus b by 2. So a, I mean to say 3, a represent 3, okay, and b represent 4. So so rational number between 3 and 4 will be a plus b by 2. So a is 3 plus 4 by 2, 7 by 2. So this is the rational number. 7 by 2 is the rational number. Okay, that is between 3 and 4. So 7 by 2 is nothing but the 3.5. So 3.5 is coming somewhere in the, if I draw the real number system. Okay, so this is the 0, 1, okay, 2, 3, 4. So 3.5 is 7 by 2 is nothing but the here 3.5. So this is the 7 by 2. So 7 by 2, the rational number between the 3 and 4. Okay, so next point is here it asking about the irrational number between 3 and 4. So how to find out the irrational number? So in the same condition, irrational number will be underscore a into b. So underscore a into b is 3 into 4, underscore 3 into 4, underscore 12. So underscore 12 is nothing but, so underscore 4 into 3. Okay, so it will be 2 underscore 3. So 2 underscore 3 is the irrational number that is between the 3 and 4. Okay, rational number. So 2 underscore 2 root 3 is nothing but 2 into, okay, root 3. Okay, it will come around okay. So this is the irrational number. Fine. So that is coming between 3 and 4. So here root 3 is less than 2. So less than 2 into multiply by 2, it will obviously it will come less than 4. Okay. So this number also exists somewhere the between 3 and 4. So here few concepts we'll talk about the irrational number. So any irrational number like underscore 2 is the irrational number. So any irrational number, if I make it negative, okay, so any of the irrational number, if I make it negative, that will be again it will be the irrational number. In other word, if I say if negative of the irrational number will be again the irrational number, and sum of the rational and irrational number is always the irrational number, because when we like sum 2 plus root 2, again it's a irrational number, and product of the non-zero rational number and irrational number is always the irrational number. So similar example, the non-zero rational number is 2 and irrational number is root 2. So 2 into root 2 is 2 root 2. That is again the irrational number. And sum of the two irrational number can be the rational or irrational number, depend on the irrational number. Okay. So two irrational number, if I take, so 4 and 4 minus root 5, and other I am taking the 4 plus root 5. Okay. 4 minus root 5 and 4 plus root 5. So in this case, the sum of these two are the irrational numbers. Okay. So sum of these two number will be the rational number. It will be 8. Okay. But if I take the two irrational number, 4 minus root 5 and 3 minus root 2, so here this will be the sum of these two numbers will be the irrational number. Okay. So now we'll take one example where we'll prove that any particular number is irrational number. Okay. So here I have taken the example root 8 plus 5 is the irrational number, that we need to prove it. Okay. So for proving this irrational number, first we'll assume that this number is rational number. Okay. So here I have written in the, just assume that underscore 8 plus 5 is not an irrational number. So just we are assuming root underscore 8 plus 5 is the rational number. So if we are assuming this is the rational number, so finally assumption should be right in the end of the solution. Okay. If it is the wrong, that means underscore 8 plus 5 is not the irrational number. Okay. Now let's see step by step. Okay. Now if I say the root 8 plus 5 equal to x, okay, just consider the x, okay, is the rational number. So just square the both the side. Okay. So underscore 8 plus 5 whole square equal to x square. Just simplify this. Okay. So finally I have written like underscore 2 equal to x square minus 33 by 20. I have written in such a way so that I can prove here, okay, this side is rational number, right side, and this is the irrational number, something like that. So if this equation is, okay, irrational, that means this is, we know that underscore 2 is irrational number. So left side is irrational number, that means right side also should be the irrational number. That's why I have written this in such a way so that I can further, okay, on the assumption basis, I can go ahead and try to prove it. Okay. So since it is assumed that underscore 8 plus 5 equal to x is the rational number, okay, so x square will also be the rational number. If x is the rational number, we have assumed, okay, because in the starting beginning underscore x plus 5 we have assumed it as a rational number. So x underscore 8 plus 5 equal to x we have considered. That means x is also a rational number, right? So x we have considered x is the rational number. Okay. So x square will also be the rational number. Like 2 is the rational number. So 2 ka square 4 is also the rational number. Like 5 is the rational number. 5 ka square 25 is also the rational number. Fine. So x square is the rational number. So x square minus 33 by 20. This is also the rational number. Fine. Because here from the rational number, x square is the rational number. From rational number, I am subtracting rational number divided by rational number. Okay, so it's a rational number. So x square minus 33 by 22 equal to underscore, okay, 2, okay, is the irrational number. Okay, because underscore 2 is the irrational number. So I am saying one side I have assumed x square minus 33 by 22 is the rational number. Okay. So root 2 is the irrational number. Okay. That equation number 2 I have considered it. So if the root 2 is irrational number, that means somewhere the x square is also the irrational number. Okay. Because if I consider this number is the rational number, okay, so the value of this number is coming root 2. Root 2 is the irrational number. That means this number itself is the irrational number somewhere, right? So our assumption is wrong. Okay. So that means x square is somewhere is the irrational number, or x is the irrational number. So whatever we have done the assumption, that is wrong. So if x is the irrational number, x is the somewhere the irrational number, okay, we have find out here. That means x is nothing but the underscore 8 plus 5 is the irrational number. So in that way we have to prove it. Okay, first we need to just assume this is the rational number. We just square it and try to write our equation in such a way so that one side we can write in terms of the x, okay, other side in terms of the underscore something, okay, so that we will right side we just try to find out like if x is the rational number we have considered, so underscore x is the rational number, so underscore x minus something by something is also the rational number. Fine. So if whole equation right side is coming the rational number, that means the left side also should be the rational number, right? Because both should be the same. If one side left side is or right side is rational number, so left side of the equal is also the rational number. Fine. Or one side is rational number, so no, other side of the equal, okay, that is also the irrational number. So in that way we need to write the this equation. This is the very important part, okay, and after that we just come to the conclusion on the basis of the x, okay, and how the left hand side is coming. So right hand side we can, okay, we can put the value of the x and we can try to find out. So that assumption we have to prove it, it's wrong, okay. So here we have proved it. Our assumption underscore 8 plus 5 is the rational number we have assumed, but that is wrong finally. So that we have proved it here, okay. So in this ways this kind of question will come. So we have to think the logic like this, okay. This is the one question. A lot of question can come in such a way, okay. So if you know the logic how to like build our equation, okay, and we can go ahead further. So in that case any kind of question we can solve it. So this is all about the irrational number, okay. So thank you very much for watching this video, and please like and subscribe for more and more videos. Thank you.